You're welcome to Biology Lectures with Akere Leola Philip. It's my wonderful pleasure to have you with me on the lecture. So today we'll be looking at question or solutions on cell level 3. That means, cell division level 3. That's the level of difficulty, actually. And I will implore you to attempt each of the questions first before listening to what the answer is going to be. So you just pause the video, read the questions, see if you can attempt the question. Afterwards, you play the video to hear what the answer is going to be. All right. It says here, figure 1 shows photograph of some animal cells at different stages during cell cycle. I want to do this with the whole view at once. Okay, we have A, B, C. All right. It says which photograph in figure 1 shows a cell that is not going through mitosis. All right. Okay. I would say, I think I want us to identify each of these cells. I mean, what stages are they in or are they on, basically? All right. So this is telophase. If you've seen my video on cell division, you will know what I'm saying, but I'm going to do a quick overview here. Then we have, this is metaphase. I'm going to tell you why I said that. Then this one is interphase. All right, now let me say quickly that in the cell cycle, you have quick brief, you have something called interphase, which is the resting phase of the cell cycle. Then after this resting phase, the next phase you have is the mitotic stage, which is divided into PMAT. The P is prophase, the M is metaphase, then the A is anaphase, then the T is telophase. Some will say telophase. Either way, that's the spelling. Now, each of these have their features. For interphase, the diagram looks like this. That's the cell. This is the nucleus. In there, you just see structures like this called chromatid. You can't really see the chromosomes. They are not differentiated. But once you go to prophase, this is what prophase looks like. So you have the nucleus like that in there. Then you have the chromosomes appearing. Like the chromosome is distinctly formed. You can easily say you have a chromosome. That's what we have there. That's prophase. Then for metaphase, you have something looking like this. Don't mind the shape of the cell. It's just the way I drew it. Okay, let me draw something more spherical like that. So this is the nucleus. All right, sorry, let me take this off, because at metaphase, the nuclear membrane has disappeared. So what you have is just the chromosomes lining up at the middle of the cell like that, just at the middle of the cell. Now, it could be horizontal. What you have on the screen is horizontal. It could be like this also, like having it like this. Either way, the chromosomes are lined up at the center. So this is prophase with a P. This is metaphase. Either of these metaphase is metaphase, whether it's horizontal or vertical. Then the next phase to that is the anaphase, which will look like this. The chromosomes will be like that. Let me just draw those things. Those dot line I'm drawing represent spindle fiber, which is an elastic protein or a contractile protein that pulls the chromatid of the chromosomes apart, so to say. So this is anaphase. So that means the chromatids are being pulled to the opposite side of the poles. Then here is the telophase, which means that the chromatids have arrived like that. So I mean, this is this, this is this, while this is this, and this is this. Hope you're getting it. So that is telophase. Then afterwards, the next thing that happens is cytokinesis, which means that the cells split into two like that, or the cells split into two. You have two nuclei there. So the point is, this is prophase, metaphase, anaphase, then this is telophase. We can call this whole part telophase really, but this actual division is called cytokinesis. Let me write that out. Cytokinesis. Now, you agree with me that this structure here looks like this because the chromosomes have arrived at different poles. Then this one at the middle looks like this. It's at the middle. It's at the middle. All right, that's what I'm trying to tell you. Then, of course, this guy looks like this. Yes. So at interface, the cell is not dividing. It's just there. It's not just there, please. It's not dividing, but it is actively doing some things. It's forming enough volume of cytoplasm to be able to go into the two intended daughter cells. It is forming enough duplicating mitochondria, the Golgi apparatus, like all the organelles that need to be duplicated are being formed so that when the cell finally gets to mitosis, all the necessary organelles are already in place. So you just go into the two daughter cells. So the answer to this question is this. All right. It is C. Why is it C? Because that's mitosis where there's no cell division at all. So you might want to rewind the video if you need to get some concept all over again. All right. It says here, describe what is happening in photograph A. Let me get these things off. Now, we already agreed that A is telophase. So if you can remember what happens at telophase, that's your answer here. So at telophase, you can say that we have 2 marks. I'm going to write more than that anyways. I'm just going to write some. I don't know. I have to go forth and back. Just trying to remember this really. But I know what the picture looks like, so I'll just write the things happening here. All right, so moving on. So it says here, describe what is happening in photograph A. Scroll, this is A. All right, okay. We already agreed that A is telophase. So that means that anything you know about telophase can actually write that here. Now, so we say that, how many marks? 2 marks. Okay. The chromosomes have arrived at the poles of the cell. Okay. There is presence of early cytokinesis. You can just say early cytokinesis. All right. You can say, or you say late telophase. Late telophase. What do I mean? Early cytokinesis. This is what I mean. This depression formed here, and it says about to divide. That's what I meant by that, really. So the chromosomes have arrived at the poles of the cells. There is presence of early cytokinesis. So you can just write early cytokinesis, basically. All right. So you can say 2 nuclei is formed. I'm just giving like another way of saying it. So each of these 3 points, 2 of these 3 points gives you your answer, basically. Okay, it says here, a student wanted to find out more about the cell cycle. The student made a slide of an onion root tip. She counted the number of cells in each stage of the cell cycle in one field of view. The table below shows the results. Okay, number of cells, we have 20 cells that are not dividing. We have 9 cells in stage 1 of cell cycle. We have 4 cells in stage 2. We have 2 cells in stage 1. We have 1 cell in stage 4. Okay, it says here each of the cell cycle takes a different amount of time. Okay, which stage is the fastest? That's going to be stage 4. And what's the reason why? Because you have just 1 cell. Because it has just a cell. Now, the next question says the cell cycle in an onion root tip takes 16 hours. Okay, calculate the length of time in stage 2 of stage 2 last in a typical, calculate the length of time stage 2 lasts in a typical cell. All right, so okay, it's going to be this way. Okay, how many cells we have in stage 2? 4. Am I right? Sorry, stage 2, yeah, we have 4 cells. It's going to be 4 over 36, which is, right, the total number. So 4 over 36. Then we have 16 hours. It's meant to be in minutes anyway, so it's going to be 16 times 60. So if you punch your calculator like I'm going to do now, gives us 106.666. It says in 2 significant figures, it's going to be 1.667. Yeah, because it's like 106.6666. So 2 significant figure, we just approximate one of that. Okay, all right, that's okay. Moving on. Bacteria such as Escherichia coli undergo cell division similar to mitosis. Figure 2 shows a curve for E. coli grown in a nutrient broth. Okay, what type of cell division causes the change in the number of E. coli? Okay, now really, bacteria are divided by binary fission. Binary fission, which is type of asexual reproduction. So the answer here should be binary fission. However, it says here at P, let me say this, when bacteria wants to divide, it goes in stages. The latent stage, when it is not really just starting, then a time comes whereby it divides so fast, and that is called exponential stage, or like increase, so to say. There at this place it is stationary, like stationary, like it becomes static, like it reduces, so to say, and there's a reason for that anyways. Now it says here, suggest why the number of cells levels out at Q. Okay, yes. The reason number one is because the nutrient availability has been reduced. Okay, let me write this way. Because of decrease in nutrient availability. So it's like they've used up. Because you can say that you can also say nutrient has been used up. Nutrient has been used up. That's the way. Now, what does that lead to? That leads to decrease in cell division, decrease in binary fission. That's the name. Now, or you can say, at this point, somebody will start dying. Yes. So it's like they will be dividing and they will also be dying. So it's going to be like more like the death rate equals the division rate. So decrease in a long run, the cell division reduces. So you can just say cell division equals, let me write that again, equals cell death. Don't forget cell death. Why? Because the nutrient has been used up, so to say.